So, I'll draw that in a moment. While the program's loading, let me just type in the data. So what do we put on the X and what do we put on the Y usually for this? Is that the door?
Y is
Let's put I
voltage.
for X.
I for X.
V for Y.
No door? V for Y.
Yes.
And on this graph, what does the slope represent?
Resistance.
Well, no, 1 over the resistance, isn't it? Yeah?
Oh.
Because resistance is V over I, and this graph is I over V. Yeah?
1 over.
Yeah. Is that okay?
No.
Is it? That's I, that's V.
Huh? X for Y.
Super, I for X. Then
X
you can
for
have
I.
Huh?
I for X.
No. It's weird, but I know earlier today we were talking about how you could swap them. For this graph, it's more common in books to put the I on the Y, which inconveniently makes the M equal to 1 over R. Inconvenient. Whereas later today, we were talking about for the EMF and the internal resistance, although we're changing the V, those graphs are usually this way around. And the advantage of that is that this point here represents E, and this is minus R. Anyways, no big deal. Let's put in the data. So the current goes from 500 down to 50, correct?
Yeah.
Whoops. And the voltage, what happens there? 10 down until 1. Okay. No. Okay.
V2 minus 1.
I know what I'm doing, even though it looks like I don't know what I'm doing. I do actually know what I'm doing. Don't worry. Okay. Insert chart. I hope you tried to draw this. Now, what's the slight complication here? It's only a small complication, no big deal, but what is the complication here? Any complication? Any problem with the graph? It's a small little problem. What's that? Guys, what's the problem? No, you don't see the problem? On the current, what's the unit for the current? Milliamps.
Milliamps.
Not that's a big deal. And what goes on the x-axis, did we say? The voltage, isn't it? So on the x-axis it's voltage in volts, and on the y-axis it's current, but in milliamps. In milliamps, okay? And let me put in the line. Okay, so that answers that question. Oh, son of a gun. I drew this. Did I? I backwards.
Good job.
No.
I
I shall fix this.
Copy. Oh.
Okay, you got that? Yeah. So this is part B. Now part C. Is this material ohmic?
Yes.
Yeah, it is ohmic because it's a straight line. So the answer for part C is a yes. Okay. Part D. extend this table to include the resistance. Okay, so let's go back over here. We need to have OR here. Now what's the formula for OR? Well, if I look here, the OR is V over I. So that will be V over I. Now we have to be careful though, because the I is in milliamps. Yeah, so just be careful. If I have OR equals V over I, and this one is in volts and this one is in milliamps, then what will my OR be in? No, it will not. No, it'll be in kilo ohms, because the milli is under.
0.
Yeah. So actually this is in kilo ohms. So if I just multiply it by 1,000, I get it back in ohms. Okay, so that's OR in ohms. And you can see here, it's 20 all the way.
So I should write 20k ohms.
No, this is 20 ohms. Originally it was 0.02 kilo ohms. Kilo, not killi, what the heck is that? That's D. It's all 20. E, what is the smallest and the largest? Well, for this one it's the same.
Yeah.
20 is both the smallest and the largest. And what does the slope represent?
Resistance.
Yeah, the 1 over 20. No. Didn't we say it's 1 over the resistance is the slope?
Yeah. Slope?
The slope is 1 over OR.
Oh.
What does the slope represent? 1 over OR.
Yeah.
What? No, what am I missing? What did I miss? Did I miss something?
No.
Huh? Is it okay?
No.
Now think about it, like, here's our graph. The slope is 1 over 20 per ohms. Yeah?
Yeah.
Okay. Alright, so that answers part 1. Oh, but I never drew the circuit, but the circuit, you have that in the notes. I'll just draw that quickly here. Do you remember the circuit? We have power, switch, ammeter, resistor, variable resistor, fixed resistor, voltage measured here. This is it here. Okay? Right. Next. Sketch the, now I don't know if I included this on yours, did I? Yeah, sketch the IV for the following. Okay, so for the first one, a simple ohmic resistor. What shape graph is that? For part A.
Straight line.
Yeah, straight line just. And I would like you to include the negative as well. So this is for part A. B, a filament lamp.
Not straight line.
Wow, that narrows it down to literally anything except a straight line. Could you be more specific? Yeah, well, what happens to the resistance as the voltage increases? Does the resistance get bigger or smaller? Bigger. The resistance gets bigger, so the slope gets smaller. So for the lamp, it goes like this. That's B. Yeah? What's wrong, Gary?
No, that's fine.
Okay. And C, the LED.
The more the voltage, the less the resistance.
Yeah, so it's actually the opposite of the filament lamp. As it warms up, it has less resistance. So the graph looks like maybe like this. This is C. But if you remember, on the negative it behaves quite differently. It does not like the current running backwards through it, and it will try to resist and have a high resistance for a very long time until it breaks, and then it shoots down off. Yeah.
When the LED broken, does it any light?
Yeah, no, I think it might flat. I don't know if it's actually broken. I say broken, but it might not be broken. It will prevent the current flowing through it like a door, and then all of a sudden the current will rush through it. So it might flash. I don't actually know. I'm not sure. I just know that it does not like the current to run through it backwards. I call it broken, but it's not really broken. The correct word is called runaway. So the current just at one point just goes crazy and floods through. Yeah. Okay. Are we okay with that? Yeah. Okay. Let me just save this. Okay. Could I just have a spare pencil, please? Thank you. Okay.